Hello everyone, welcome to Stochastic Calculus for Finance 1. This is section 3.3 where I walk through the optimal investment problem. So to give a formulation of the problem, so imagine we have an agent that starts with an initial wealth of x0. This is how much money they had at the beginning. And they want to maximize the expected utility at the future time period in the future by investing in the money market and in a stock. And the wealth equation, as we have seen in the previous sections, is defined by this equation. This is just the basic wealth equation we have seen in a one-period binomial model. So how can they do this? Really divide the strategy, and by strategy, then at each period they need to find what is the optimal amount of the stock they need to buy. Hence, and the remaining they will invest that in a money market security, so that they can maximize the expected happiness at a future time period. And note here, when we say maximize the expected future happiness, we're really caring about the real world probability, right? And the reason is imagine if we use here instead we were using the real risk neutral world. So that means in the risk neutral world, each investor, each asset actually will really return the risk-free rate R. So if you have an investor that's actually risk averse, they will never invest in a stock. They will invest all their wealth in just the money market. But since we have this averse investor, so it makes sense to really use the real world probabilities. Okay, so let's go through this. So imagine we're using this two-period binomial model, and this binomial model is actually compatible with these parameters: the initial value of the stock, this is the up factor, the down factor, the interest rate R. And given this period, an investor that starts with x0, and let's say x0, the investor is starting with a wealth of $4, how can they invest to maximize the expected utility in the future time period, at time period 2? So using these parameters, we can find the risk neutral probabilities. We have seen how to calculate this fairly easily as well, using these parameters. Then just for a moment, let's imagine that actually the real world probabilities are this given here. So a few things to remember. Remember, the wealth equation is defined by this. The utility function. For the utility function, we're using the log ln, as we have seen before. And our goal is to maximize this expression. We want to maximize the expected utility at time 2. So okay, so let's do this. So what would be our wealth at time 1 if our wealth follow this this wealth equation? So at time 1, if we get head, our wealth will be equal to this amount, and if we get tail, our wealth will fit this. And if you want to know, I can show you where these numbers are coming from. Actually, it's not that complicated. So x1 h, we just apply dumbly this formula. So at the start, you're gonna buy data 0 of the stock, right? And that Sn plus 1. So at the time 1 we had h, so it's gonna be S1h, because we imagine we flip the coin first in this case, and we got h. And S1h is actually nothing but 8. So this S1h is really 8 here, and that's where you see this 8 is coming in. Plus then the 1 plus r. Our interest rate is 0.25. That is just our interest rate is 1/4, right? So then 1 plus 1/4, that is just this 5/4 that we're seeing here. And xn, our initial wealth, we started with $4, and then we spent data 0 of our initial money to buy the stock, and the stock was costing $4. So as you can see here, basically this is the amount of money we left off after we buy 4 data 0 shares of the stock, and that we invested that in the money market at this and hence it will be compounded the next period to this amount. And this is just the value of our stock portfolio if we flip the coin and we get a head. So very simple. And it's the exact same formula that we apply at this point also to find this amount. Okay. And then if we flip the coin and we get head twice, right? Then again, we just apply this formula here. The exact same formula, that's what we apply. So x1 hh, we just like the, in this case, delta n will just be, since we're like at time 2, this is delta 1, and that's what we're seeing here. And that's like how our value of our investment, if we flip and we get head. And this is the value of the stock as given by this formula here, right? And this 5/4 is coming again here. This is just the interest rate compounding. This is the value, our wealth at the previous time period. Since we are sending at time 2, then this is the wealth at time 1. Given that we had a head, we had a head at the first coin toss, I will see here. So this is just like some really simple algebra that we do here, and we can do that for every single result of the coin toss. And for every single coin of coin toss, not like the value of our expected ln of x, our wealth at time 2, is given then as a function of a few things. It's a function of delta 1h and the amount of initial stock that we bought at the start in different scenarios. So we have like the value of our wealth as a function of these delta 1, and this is what we're trying to find. We're trying to find basically the strategy, how much to buy or sell, how much of the stock do we need to own at each time period, whether we get a head or a tail. So doing that, then we can really find the expected value of this function, of this value, right, the ln of x. So the probability of getting head is 4/8. So that's where this 4/9, sorry, and that's where this 4/9 is coming from. And then we'll multiply by ln of x h, right? And that's where this value is coming from. Actually, if you look closely, this value here is nothing but this value here, right? And we keep doing that for each scenario. And I'm sure you know this, but I will just repeat it here to make sure like we're on the same page. The expected value of ln of a random variable x2 is nothing but the probability that x2 is equal to one of the event x time ln of x, right? And then we sum this up over all the x's. So that's all we're doing here. This is just the basic properties of expectations. And if we look at this formula here, now all we need to do is really maximize this expression, right? We just want to maximize this whole expression here, where the only unknowns are like these values. So this is a very simple mathematical problem that we can resolve, and we can find exactly how much this amount are. Computers are pretty good nowadays to do this, to crunch these numbers. So if you want to see how to get these values, you can just use any optimization method, maybe Excel or whatever, and we'll get it. And the solver in Excel will give you these numbers. So that's how. Hence we have like, this is then the optimal strategy. If we stand at time 0, then the best thing we can do really for money, if we start with a wealth of $4, is buy 5/9 share of the stock and invest the remaining amount of money that we get in the money market. Then as we move forward, if it turns out that next period the stock price went up, then the best thing we can do is we need to make sure that we own this many shares of the stock. If our current holding is more than this, then we will sell some stocks. If our current holding is less than this, then we'll buy some more stock to get to this fraction. But if in the other case, like the stock went down, then actually we should be making sure we own this amount of shares of the stock. So we will trade again as when we stand at this time period here, and that's our strategy. Thank you very much for watching. And in the next videos, I will show you that actually this works, but since this is a tree, and we see that this is a function of all the deltas, right, at each time period. So this is actually, these deltas grows actually at an exponential rate, because we need to take the deltas at each node of the tree, and these grow exponentially. So next period, I will show you how to really find the optimal investment strategy as well, just by using the nodes at the end of the tree, which is much better because we do less computation. And I will show you that in the next video. Thank you very much for watching, and I haven't said this so far, but please feel free to subscribe, comment below. Thank you. Bye bye.